Look at these two examples right here. Can you notice any difference? On one side, you can see artifacts everywhere, shimmering edges and shadows, glitchy reflections, lighting that never settles. Clearly the difference is hard to ignore. Now, what if I told you most of what you're seeing on screen comes down to one single thing? It is called temporal anti-aliasing, or as people like to call it, temporal approximate anything. Jokes aside, temporal anti-aliasing is actually a deep rabbit hole, but plenty of people have written about the good, the bad, and the ugly about Unreal Engine and its recent features. What I want to talk about today is why optimization is the #1 complaint about Unreal, and how developers and users keep talking past each other. Is it the fault of the engine, Epic, or maybe the developers? Spoiler alert, it is complicated. Everyone knows what Unreal Engine is, how popular it has become, and how much it has made digital productions accessible to all, basically anyone with a computer and a pulse. But this is where the problems start. Unreal is extremely accessible, and the barrier to entry is very low, as you can get impressive results very quickly, not to mention that it scales extremely well. You can be a solo indie developer or massive production team working on games, films, archivist projects, engineering, motion graphics, and everything else in between, and you might start to see the issue here. Because Unreal needs to serve so many people across different fields, from games to films to virtual production to architecture, it has to appeal to the lowest common denominator, which makes it an engine that gets results fast and relatively easily, but faster and easier is not always better. This is one reason why Unreal gets so much criticism. For many, the engine has become synonymous with bad performance, stuttering, shader compilation headaches, and inconsistent frame rates. To be clear, this is not always the case, but for some this is a real problem. That being said, the truth is optimization is a shared responsibility. Unreal absolutely has a lot of room for improvement, especially when it comes to the default implementation of things like shader compilation and caching, temporal anti-aliasing, and TSR tuning, in addition to virtual shadow maps and post-processing stacks, which are enabled by default. Many of these systems are powerful, but their baseline settings often prioritize visual quality and ease of use over performance and predictability. But on the other hand, many developers, especially less experienced teams, rely heavily on those defaults and high-level systems without fully understanding their cost. It is easy to load very heavy assets, stack post-processing effects, copy blueprints, and assume the engine will handle performance automatically. You see, when a small scene starts running poorly, it is usually not one single feature, but the accumulation of many expensive choices made without a performance plan. This in part might fall on the marketing that Unreal keeps pushing. Like many others, when I watched the Unreal Engine 5 demo, I was blown away.
16 times the detail.
Seeing all those statues lining up, and their numbers, 16 million trillion polygon faces, whatever lumen, nanite, and all that, which gave everyone, including me, a very false idea about LOD, big GI, and optimization, which we thought is gonna be a thing of the past. I mean, we thought we can grab things from ZBrush and throw them straight to Unreal and start working on something. And here's the rule. If something sounds like it is too good to be true, it probably is. As we all know, the scenario I just played out was not the case. Call it whatever you will, false advertising, overselling, or whatever, but the Unreal Engine 5 release caused a shift. On one hand, Unreal is capable of delivering cutting-edge visuals and performance using these features, but it is not the silver bullet that everyone thinks it is. Experienced developers and artists plan ahead. Rarely do you find a commercial Unreal Engine, I mean a big game using Unreal, running completely on default settings. There is almost always tweaking and optimization happening under the hood, from level of detail groups, texture atlases, and optimized blueprints, or maybe C++ code, to correctly implement expensive features like Lumen and Nanite. These features can drastically impact performance if not used carefully, which is why understanding the engine system is essential for stable and efficient results. So now that we got an idea, of the problem at hand, what can be done to improve Unreal optimization and bridge the gap? First, let's address the elephant in the room: temporal anti-aliasing, Lumen, Nanite, and other Unreal Engine features. As much as people like to criticize Lumen, Nanite, and probably other stuff, these things are not inherently bad. They try to solve real problems and enable things that were previously impractical, but you need to know what you're doing. For example, using alpha materials for foliage is gonna look bad if you're using Nanite because you are doing it wrong. And this is where a lot of frustration comes from. For instance, Lumen's only problem is that it is framed as a default modern path, not as a choice, with real trade-offs like higher baseline CPU cost, temporal instability, and hard to debug edge cases. For many projects, baked or hybrid lighting still looks better and runs faster. Nanite, which simplifies asset authoring and handles dense static geometry, does cause other problems like shifting workload onto the GPU, as material, shading, and overdraw costs, especially with the foliage or deforming meshes. It also performs worse with less dense geometry, where traditional LODs make much more sense. And finally, temporal anti-aliasing. I just found out recently that there is a whole subreddit, quote finally FTAA, focused solely on pointing out, as they call it, over-reliance on blurry temporal-based algorithms, which are plaguing modern video game graphics. Temporal anti-aliasing, such as TAA, is effectively required to achieve a stable result from Lumen, Nanite, and many other systems in Unreal Engine 5. These systems rely on temporal accumulation in history to convert to a usable image. They are designed to work together, not in isolation, and because of this tight coupling, there is some merit to the criticism around Unreal's over-reliance on temporal techniques. If you want to learn more about Unreal optimization and its problems, I can point you to some great videos to learn more about the subject, such as the Unreal Engine problem from the creator, the Jedi Exile. So to answer the question of this video, is Unreal Engine overrated? Well, personally I think Unreal Engine deserves all the praise it's got, but it is also fair to point out some shortcomings, in addition to some missteps, which I think of course need to be corrected, to deliver optimal gaming experience, which would go a long way. Instead of showing a new toy every version, they should build upon what works and spend time documenting and enhancing the stuff that matters. So there you have it guys. If you like this video, please give it a thumbs up. Also please subscribe to this channel to receive more videos like this. Thank you very much for watching, and I will see you in the next one.